I'm happy to welcome back all the participants for the hands-on session of Python Basics. Today, our resource person is going to be Dr. S. Shanti, Associate Professor, KEC. Dr. S. Shanti is having more than 20 years of teaching and 10 years of research experience. Her area of interest includes data analytics, image processing, pattern recognition, and soft computing. She received grants from various funding agencies like AECT, CSIR, DBT, ICMR, and DRDO to organize national and international seminars, workshops, and conferences. She delivered invited talk in image processing using MATLAB, data mining using Vega, and data science using Python. She completed her PhD in 2015 in computer science and engineering at Anna University, Chennai, India. She has published more than 30 research papers in various national and international journals, currently guiding 4 PhD scholars in Anna University, Chennai, and 2 scholars completed PhD under her guidance. She is presently working as an associate professor in the Department of Computer Science and Engineering, Kungu Engineering College, Tamil Nadu. Today, he is here with us to share his expertise in Python basics for deep learning. I'm happy to welcome Dr. S. Shanti. Now I hand over the session to Dr. Shanti ma'am. Shanti ma'am.
Yeah, thank you, Dr. M. Payangodi, for nice introduction. Now I will once again good afternoon to all. Now I share my window. Am I audible? Yeah. So you are able to see my window?
Yes, ma'am, it is visible.
Yeah, thank you. So today I will explain some basics of Python. So because in the participants are coming from different disciplines, some of you know the basic concept of Python, some may not aware of this basics of Python. So I am starting from basics. So Python is a dynamic, high level, free, open source and interpreted programming language. It supports object-oriented programming as well as procedural-oriented programming language. So it is used for scientific and numeric applications as well as in web development for client-server programming and in game development. So mainly it is used in artificial intelligence, machine learning and deep learning, and also used in software development as well as in enterprise level business applications, and many more areas the Python is used. So why this Python gets most popularity means it works on different platform. So we can execute the Python program in Windows operating system as well as in Macintosh, Linux. The only thing is the machine has to have a Python interpreter, that's all. So it has a simple syntax. So in Python, no need to declare the variable before using it. If you take C language or some other Java language, before using a particular variable, first we have to declare the variable. Here no need to declare the variable. So depending upon the value assigned to that variable, it will assume the data type. So another one is it is an interpreter system. So whenever you complete the first statement, immediately it can be executed. So that is called as interpreter. So why we are going for this Python means because of this reason. So for example, if you want to print something, it's enough to say print off, then you can say your content what you want to say. Okay, if you take C language or some other Java language, you have to follow so many syntaxes. You have to write the main, and if it is a Java, you have to write the class, everything. But in Python, it is very simple. So what are all the different data types available in Python is, suppose if you want to have a text type, we can have the data type is string. For numeric type, integer, float, and complex type is there. So this is A plus complex means A plus IB format. Then sequence type, suppose if you want to store multiple values under the same name, we can go with list, tuple and range. So these are all called as sequence type data types. Mapping type, suppose you want to have a key value pair. Suppose we are having a phone number and it's corresponding with name. So this is called as key value pair. So if we want to store an information in this order, we can go with dictionary. Okay, it is an example of this mapping type is it is a real-time dictionary. So here we are having a word and the corresponding values, meaning of the word. Okay, then set type. So here we are having different types of set. That is it, what we discussed in maths. Okay, by using set you can do intersection join operations. Okay, then Boolean data type, that is true or false. Then binary data type, it's byte, array, memory tube. These are all the basic data types available in Python. It is similar to the languages like C and Java. So here, for example, here there is a statement x equal to hello everyone. So here this hello everyone is a string. So as I already told here, there is no need to define the variable. Simply we are assigning the value to that variable. So depending on the type of value, this will assume the data type of this variable x. So here I am printing the type of x. I am not printing the value of x. I want to know what is the data type of each and every variable. So I am printing the type of x. So it will print the data type of x is string. Okay. So in Python, everything is treated as a class. So it will say the output is it is a string class. Okay. Then the second example, I am assigning x equal to 20. So here 20 is an integer. So this will assume that the data type of the variable x is integer. So third example is here x equal to within square bracket. So anything within any element within square bracket, it is called as list. So as I already told, there are different data types. So anything within square bracket, it is called as list. So here this Python compiler, Python interpreter will assume that x is a list data type. So if the Python is very simple, here no need to declare the variable. So depending upon the value assigned to the variable, it will assume the data type of that variable. So here it assumes that the data type of x in third example is it is a list. So similar to C and Java language, here also that statements are there. If statement that is similar to C, if you will write the condition, then condition is true, you will have a block of statement. Then there is a for loop. So here the for loop is little bit different. The general syntax is for iterating variable in sequence, then colon. Here to define the block of for loop, here it is terminated with colon. So for this is a iterating variable, in is a keyword, then sequence. Here this is a Python is a string. So here the sequence may be a string or maybe a list or it may be a tuple. Okay. So here what it will print is, it will print current letter colon. First it will print p. In the next iteration, y will be assigned to the variable letter. In the second iteration, it will print the current letter is y. Third iteration, it will print t, etc. It will print all the letters one by one. Finally, it will print goodbye. So in this for loop, only this print is the print of current letter will be there. So here Python is here we have to follow the indentation. In C, there is no need to follow the indentation. So if any statements within this for loop means all the statements should be written in this column line. Okay. So up to this we have to leave some spaces. This is called as indentation. So Python is an indent. We have to follow the indentation in the Python programming language. Okay. So after colon, here only one statement is within this for loop. So we have to have a common indentation for all the statements which belongs to this for loop. Okay. So this is outside the for loop. So here there is no indentation. So this will print current letter P, current letter Y, current letter T, etc. It will print up to N. Then finally it will print goodbye. So this is one version of for loop. Another one is range. So in C programming, you will display for I equal to 1 to 10. So that loop is repeated for 10 number of times ranging from 1 to 10. So here also there is a ranging statement. So here range, the lower limit, comma, upper limit, Then we can have an increment or decrement. This increment and decrement is optional, means it will increment 1 by 1 or it will do decrement 1 by 1. Then here we can have a colon, then we can have a block of statement. So this range is combined with this for loop to generate a sequence of numbers between this lower and upper limit. So for I in range of this R is not capital, it is small. For I in range of 1, 6. So inside this for loop, there is only one print statement. This will print the value of I. So this loop is repeated from 1 to 5. Okay. So always this range works starts from lower limit and ends with upper limit -1. So here upper limit -1 is 5. So it will display I equal to 1 to 5. Another one is there is an increment option is there. So 1, 6, the lower limit is 1, upper limit is 6. So each time it is incremented by 2. So this will print 1, 3 and 5. So this is small variation in the for statement. So another one is in Python, there are a rich number of libraries are there. So these are all the some basic libraries. One is NumPy. So NumPy stands for numerical Python. This contains so many functions for manipulating the numbers. Example is basic linear algebra functions, Fourier transformations, etc. So NumPy is the fundamental library of Python. Mainly it is used to perform scientific computing. That is NumPy. Another one is Pandas. This is for structured data operations and manipulations. Here this Pandas mainly work with tabular data. So NumPy work with multi-dimensional, that is numerical data. So here NumPy works with the numerical data. This Pandas mainly works on tabular data. Okay. So both will use it to manipulate the data. Another one is Matplotlib and Seaborn. These two libraries are used to visualize our data. So this Seaborn will give a rich amount of visualization of data than this Matplotlib. Okay. Suppose we want to visualize our data, we want to see our data in a graphical manner, we can use this Matplotlib or we can use this Seaborn. Then scikit-learn, it has a different number of functions for performing this machine learning tasks. Okay, in machine learning there are different supervised and unsupervised algorithms are there. So in this scikit-learn library, it consists of the different algorithms to performing this machine learning and deep machine learning. Then in statistical model also, it is used to perform this statistical operations. So to perform all different types of manipulations, we need the data. So this Blaze is used to access the data from multiple sources. Okay. You can take the data from different sources if you use this Blaze library. Another one is SciPy. This is also a scientific Python. It is also for performing this mathematical operations. This SciPy is used to display the result in a LaTeX code. Okay. So you are doing so many computations. If you want to format your result in a LaTeX code, we can use this SciPy. Another one is Request and Scrappy. These two libraries are mainly used to access the data from the web pages. Suppose there are so many social media data also there. There are Facebook, LinkedIn. Suppose even there are so many websites are there. So from that website, if we want to access some data, this Request and Scrappy will useful to access that data. So these are all some basic libraries. So first we will see the NumPy. So NumPy stands for numerical Python. It is mainly used to work with the arrays. So here this Python list. As I already told, list is a data type. So in list also we can have this list is similar to arrays, but they are its slow process. So that's why we are going for this NumPy. This NumPy is called as ND array. It provides a lot of supporting functions that make working with the ND array very easy. So this is how to create a NumPy array. So the first one is, it is similar to C language, we have to import. So here we are importing the package NumPy, import NumPy as NP. So NP is the alias name. So either we are creating an array with 5 elements. Here we are using a np dot array. This array is a function which is available in the package NumPy. Either directly you can use NumPy dot array of 1, 2, 3, 4, 5, or we can give np. So here the package name is very long. If we use directly the package name, it is very difficult to code it. So instead of that, we are using this alias name, import NumPy as np. So instead of NumPy, we can use np in the coding part. So here we are creating an array, NumPy array with 5 elements. So anything within square bracket, it is called as list. So the list is converted into an array that is stored in the variable ARR. So here I am printing the content of array. So this will print 1, 2, 3, 4, 5. This is the content of the array. Next, print type of array. Here the type of array is, this is NumPy ND array. The type of this variable ARR is NumPy ND array. So this is an n-dimensional array. It is created using a NumPy. So it is the data type of this ARR is NumPy ND array. So how we are accessing the array element means by using the index. So here you can use an integer index. If ARR 2 means it refers the third element. Always array index starts from 0. So this is 0, 1, 1 and 2. So this will display 3. So this will print ARR of 2 will display 3. Okay, this is very basics of NumPy 1D array. So this is a 2D array. How to create a 2D array? So as it is, import NumPy as np dot array of, you are creating an array. It is a 2 dimension. It consists of 2 rows. So first row consists of 1, 2, 3. Second row consists of 4, 5, 6. Each row consists of 3 columns. So this will create an array with 2 rows and 3 columns. It is a 2D array. So this will print the dimension is 2. Dimension is 2. This is the content of the array 1, 2, 3, 4, 5, 6. So how we are accessing the array elements. So here we can use positive indexing as well as negative indexing. So Python supports both positive as well as negative indexing. So this is our one-dimensional array. It consists of 4 elements. So this is index positive index. 0 refers 10, 1 refers 20, etc. 3 refers 40. This is negative indexing. If it is -1, so the -1 refers the last one, last element of the array. -2 means from last to second element. So if you say a of -2, this a of -2 refers the element 30. If it is a of -4, it is 10. So this is negative index. In Python, it supports negative indexing as well as positive indexing. If it is 2D array, if it is 2-dimensional array, a of 1, always array starts with 0. So a of 1 means it refers the second row. So second row, in second row, the element is -2. Second row, the element is -2. So it refers 50. Okay. So a of 0 means it is first row. The element is -1. So a of 0, the element is -1. So it refers 30. If you say simply a of 0, it refers the 0th row. It will return the entire row itself. Next one is array slicing. Suppose you want to divide the array elements, or you want to extract a part of the array. This colon operator is used. This colon operator is very powerful operator. So in later cases, while we study machine learning algorithm and deep learning algorithm, in many places we will make use of this colon operator. So by using this colon operator, we can extract the portion of the array. Okay. So the syntax is start colon end, or we can give start colon end colon string. See here, we are creating a NumPy array with 7 elements. NumPy array with 7 elements. Here we are printing array elements from starting location is 0. So then we are printing up to 5 locations. So starting location, this is 0. So starting location 1 is here. So this will print 2, 3, 4, 5. So this is the index of the array. So starting index is 1 and ending index is 5. So this will print from 2, 3, 4 and 5. If it is -3 and -1, the starting index is -3 and ending index is -1. So here already we have seen that negative index. So based on this negative index, it will start from -3. This is -1, this is -2, this is -3. So -3 means starts from here 5, 6, always ends with -1 plus 1. So here ends with 6. So it will display 5, 6. Okay. So here the starting index is -3, end index is -1. So this will display -3 from -1. Here either we can use a positive indexing or we can use a negative indexing. So this colon operator is used to extract the part of the element. Another one is the same colon operator, the same array. It consists of 7 elements. 7 elements. Here we are displaying the first argument is start equal to 4. So the starting index is 4. Colon, the end is not defined. So the end is not defined means it will display till the end. So it will display till the end, 5, 6, 7. So in this case, the starting index is not given. The starting index is not given, but the ending index is given. So from start of 0 to index 4, it will display. So start of 0 is 1. So it will display up to 4 index, 1, 2, 3, 4. Okay. So here the starting index is 1, ending index is 1. Ending index is 5, sorry. Then each is incremented by 2. So this will display first one is 1. So this is the first one. The element 2 is the index position 1. And next it is incremented by 2. Next it will print 4. Next incremented by 2, it is 6. So this is greater than the upper limit. So it will not print. So it will print only 2 and 4. So this is a colon operator with array. Another one is copy and view. This, if you want to create one more array with the same data, you can use this copy. So it will copy function will create a separate copy of the array, but view you can create. View will not create a separate copy. It will share the same copy. So this is example of copy. So this is array. Here we are creating one more copy X. Then in the existing array we are changing the value of 0th element. Then you are printing both the element. So whatever your changes you have made in array will not be reflected in X. That is called as copy. So this is X, this is your array. Then if it is copy, the same thing. If it is view, so when you use view statement to create another variable, it will refer the same memory location. So whatever changes you are doing in array, ARR will reflect in X also. So here ARR of 0 is changed as 42. Now this is changed as 42. That is reflected in the variable ARR as well as in the variable X. That is copy and view. Another one, how to display the array elements. Suppose if you want to display the array element one by one, we can make use of the print for statement. So here you created an array with 3 elements. Then we are using for X in array. So already we have seen the syntax of for statement. Here you can have a sequence. So for X in array has 3 elements. So it will display element by element. So it will display 1, 2, 3. This is for one-dimensional array. If it is two-dimensional array, so this is two-dimensional array for X in ARR. So first the element of two-dimensional array is first row. Okay. So first in X you will have the first row. So it will print the first row. In next iteration it will print the second row. Suppose if you want to print element by element inside the for loop, again you have to use one more for loop to display element by element. So by using for loop, we can access element by element of the array. Then concatenation. Suppose we are having two arrays. You want to combine two arrays into one array. We can make use of the function concatenate. So this function is available in the class, in the package NumPy. So we are using np.concatenate of two arrays, array 1 comma array 2. So array 1 consists of 1 2 3, array 2 consists of 4 5 6. So the final resultant array will be 1 2 3 4 5 6. So this is concatenation. This will do the concatenation along column. So by default is either you can concatenate either in row wise or in column wise. So for that, this element access will be used. Access is one of the argument of this concatenate. The default is 0. The default is 0. If you say access equal to 1 means this will do concatenation along row. So the first row will be 1 2 3 and the second row will be 4 5 6. If you give access equal to 1 here, we will see that one. Okay, this is with respect to two-dimensional array. This is array 1. So array 1 consists of 2 rows and 2 columns. Array 1 consists of 1 2 3 4. That array 2 also 2 rows and 2 columns. When we do concatenation, the dimension of the array 1 and array 2 should be same. Okay, then only we can do the concatenation. So concatenate, we want to combine these two arrays in access equal to 1. In row wise, we want to combine. So 1 2 5 6. 1 2 5 6 will be first row and 3 4 7 8 will be second row. So this is along the row wise. Another one is split. Split is to divide the array into multiple number of arrays. So here in the first array, it consists of 6 elements. Now we want to split the array into 3 number of subarrays. Okay. So here we are using np.array_split. This is the function which is available in the NumPy package. So array_split of, it takes the first argument is array name. The second argument is the number of split. Here the number of split is 3. So this original array is divided into 3 arrays. So first array consists of the element 1 2. The second array consists of 3 4. The third element consists of 5 6. So totally in this array we are having 6 elements. So when you give the number of split equal to 3, so it will do 6 by 3 and in each array it will have 2 elements. Suppose you are having 7 elements in the given array, it will say an error. Okay. So how it will divide the sub array means, first it will calculate the number of elements in the given array. So here the number of elements in the given array is 6, and we want to divide that array into 6 number of subarray. So 6 by 3. So it is an integer one. 6 by 3 equal to 2. It should be an integer. Then only it will do array split. Otherwise it will say an error. Another one is var function. Suppose we want to search a particular element as exist in the array. We can make use of this var. np.var. This is array name. We want to check whether the element 4 is exist in the array or not. So np.var. Var is a function. Then the first, this is a relational expression, array equal to 4. So in this array, there are 3 number of 4 is present. So it will return the index of all the 4. So index of first 4 is 3, index of second 4 is 5 and 6 respectively. So it will display the index of the corresponding element. If the element does not exist, it will return a null value. Then another one is sort. So this is to sort the array element. So here it will be in sorted order. Then next one is random number. If you want to generate a random number, we can make use of the function randint. Another one is rand. Here there are 2 functions used. One is randint, another one is rand. So random is a module. So in this module, there are so many functions. One of the functions rand int, another one function is rand. So this rand int function is used to generate a integer random number between this start and end. So here we have given x equal to random dot rand int of 100. So this will generate a random number from 0 to 100. Here the start limit is not given. If it is not given, by default it will take it as a 0. So this will generate a random number from 0 to 100. Then this rand function will generate a floating point random number. So this will generate an integer random number. This rand function will generate a floating point random number between 0 to 1. So if you give any specific range, in that range it will generate. So if you want to generate more than one random number, you can use, this is the range. It will generate a random number from 0 to 100, and it will generate 5 random numbers. So it will generate the 5 random numbers. Here, if you give size equal to 3, 5, if you give the sizes in 2-dimensional, this will generate 3 into 5 random numbers. 3 rows, each row consists of 5 columns. So this is a 2D array. So this is an integer random number with 3 rows, and each row consists of 5 columns. So when you manipulate your data set, sometimes you need to generate the random numbers. So in that case, this random function is used to generate the random numbers. Next, we will work this basic concepts of Python. So there are different platforms are there to work with. One is Google Colaboratory. So here, in this Google Colaboratory, it will allows you to write and execute Python in your browser itself. So here, no need to install anything. Directly you can work with. Then if you want to work with, you can install the Jupyter Notebook and you can work, or you can install Anaconda. These are all the different environment to work with. If you have any doubt in this, you can share it in the chat window. Otherwise, we will go with the. So if you want, you can work with parallelly. So if you want to work with Google Colaboratory, you can type here Google Colaboratory. It takes you to the Google Colab. So if you want to work with Google Colab, you need to sign in the Gmail account. Okay, so here you can type. Here you can give new notebook. Here you can give new notebook, and you can open a new notebook. So I already signed in with my Gmail account. So this opens a new notebook in my Gmail account, in my drive. Okay. So here no need to save, automatically it will do save. So here you can change you can give the name to your program. So I am giving sample. So here no need to save, automatically it will save. So here you can give sample dot, this is my file name, sample. So here I can type my first statement, first code. So here I have typed my first code. If you want to execute this statement, simply you press this button, or you can, to run the cell, you can press Ctrl plus Enter. Are you able to see the screen? This screen is visible?
Visible, ma'am.
Visible. Okay, so this is my simple statement. So I am giving print welcome. So this is to execute that statement. So this will execute, the output will be displayed here. Okay. So here there is two options. One is code, another one is text. Suppose if you want to give some comments before your code, you can do this text. So this is nothing but a comment. Then you, if you want to create some other code, you can simply give code, and you can give, you can type your statement a equal to 10. So I want to know the data type of this a. So print type of a. So this will print the type of a. So here it will print the type of a, this one. Okay. So here automatically this will be stored in my drive. See, this is my drive. So automatically it will create a Colab notebook in your drive. So this is the first time if you are working, means automatically it will create a Colab notebook in your drive, and inside this drive the Colab notebook is stored, that is sample.ipynp with this extension. So now we will see this statements one by one. So whatever we have discussed till now, we will see the hands-on of all the things. Okay, first one is simply print. So this will print hello everyone. And then this will print the type of x. So type of x is here string. So this will print x equal to string. Next one is a equal to 20. So here it is an integer, b equal to 3.6. It is a floating type. C equal to 1, 2, 3, 4, 6. And then I have given Python, that is within square bracket. As I already told, anything within square bracket, it is called as list. So here d equal to 1, 2, 3. Anything within parentheses, it is called as set. So anything within curly braces, it is, sorry, anything within parenthesis, it is called as tuple. Anything within curly braces, it is called as tuple. Then if you are having a key value pair, it is called as dictionary. Okay, now we will see what are all the data types of all the things. Okay. So here the data type of A is integer, the data type of B is float, the data type of C is list, the data type of D is F. Anything within open parenthesis, that is parenthesis, it is called as tuple. Anything within curly braces, it is called as set. Then this di equal to a colon apple comma b colon bat c colon cat. This is called as dictionary, key value pair. Okay. So this will display the different data types of each variable. So here no need to declare the variable. So based on the data type, based on the value which is assigned to that variable, it will assume the data type. Next one is print di. This is di. So if I am giving the key, here a is called as key. If I am giving the key, it will give you the value of the corresponding key. So the value of the corresponding key is a. So it will display apple. Okay. So this is another one. See, it will display the entire. If you simply type the variable and execute it, it will display the value of that variable. Suppose while you do some computation, if you want to see the intermediate results, you can use this type of interpretation. Okay. Another one is by using for loop, you can display the element one by one. For I in C, so this is the C. In C we are having 1, 2, 3 for up to Python. So it will, next we are giving for I in C print of I. So this will print element by element from the list C. So this will print 1 to 10 on Python. Next, with respect to range, for I in range of 0, 3. I in range of 0, 3. So it will print from 0 to 3. Okay, this will generate the value from 0, 1 and 2. Here we are printing d of I. So this will print d of 0, d of 1 and d of 2. So it will print only 2 elements. Okay. So suppose if we want to know the number of elements in the given list, we can use this length of C. So length of C will give you the number of element in the list. So number of element in the list is 11. So the length of list will give you the number of element in the list. Another one is by using for loop, we are printing all the elements in the C by using length function. So this will generate an index from 0 to length. So by using the C of I, we are printing all the elements of the list C one by one. So another one is colon operator. Another colon operator. Suppose if we want to extract only the portion of the element, this colon operator will be used. So this will take the element from the location 0 and up to 3 minus 1, 0, 1, 2. It will take 0, 1, 2. So this will print 1, 2 and 3. 1, 2 and 3. So this is a two-dimensional array. This is a 2D array. Here we are printing the two-dimensional array value. So here this will print this is we are creating an array by using this NP. So this is called as NumPy array. So here it will print the data type of A is NumPy array. So here this will print, first print will print the entire list. The second print will print only the 0th element. So 0th element is 1. So if you want to know before performing any executing any machine learning algorithm, we should know insight of the data. So here this that is NP array dot dimension will give you the dimension of the array. So here the dimension is 2. So this is a 2D array. So it gives you the dimension of the array. So print A of 2 will display the content of the array. Then negative indexing. So this print will print the entire array 1, 2, 3, 4, 5, 6 and print A2 of minus 2. A2 of minus 2 print the last row. Minus 2 means it will list the last element in the two-dimensional array. So last element is, this will point the last row. So this print A2 of minus 2 will return the last row. A2 of minus 1 comma minus 2 print this minus 1 refers the last row. This minus 2 refers the second, from second the last two element. That is, it will print the 8. Okay. So A2 of 2 negative indexing. The first one refers the row. The second one refers the column. In last row, the second column from last. Okay. So this will print 8. The first one print 7, 8, 9. The second one print 8. So this is very basics of Python. Next, suppose if we want to extract a part of the array, we can use this slice colon operator with two-dimensional array. So this is a 2D array. So here you see A2 of colon. So here the starting index is not given. Then comma. So this will return a third column. This will return a third column. You see this value. So this is the given matrix. Okay, A2 of all row in second column. All row in second column. So this will print 3, 8, 13. So this index is 2. So always starts from 0. This is 0. This is 1. This is 2. So this will print third column 3, 8, 13. This will print 3, 8, 13. Okay. So next one is print second row. If you want to print second row, print of second row, that is A2 of 1, that is first index, it will print all column. So in this row, this will print this row, 6, 7, 8, second row. In second row, it will print all columns. So this refers the row index, comma, the second one refers the column index. Here, if the any integer is not specified, the meaning is all column. Okay, so this will fetch A2 of 1 colon comma 2, 1 colon comma 2 fetch first row to all, okay, from first row to all, and the third column. So this comma 2 refers the third column. So from first row to all and third column is 8 and 13. This is first row to all rows, and it will fetch only third column. So 8 and 13 will be displayed. Another one is reshape. So sometimes when you use this machine learning algorithm, it will accept the data in a particular dimension. So in that case, we need to reshape our data. So we can use this reshape function. So this array consists of 5 elements. Then we are displaying the dimension of the array, reshape of 5, 1. So this is one row which consists of 5. Okay, the dimension is 1. Now we are converting the data into a 2-dimensional array. That is, it consists of 5 rows. Each row consists of 1 element. So this is the given array 1, 2, 3, 4, 5. Next, we are printing the dimension of that array. It is a 1-dimensional array. Then we are reshaping it into 5 rows. So it consists of 5 rows. Each row consists of only 1 element. So 1, 2, 3, 4, 5. Now the dimension of A4 equal to 2. We are converting our 1-dimensional array to 2-dimensional array. So in reverse also we can do. We can convert this 2-dimensional array to 1-dimensional array also. So reshape is used to change the dimension as well as number of elements in each dimension. Here you see another one example. It is a 2D array. It consists of 2 rows. Each row consists of 4 elements. The dimension of the array is 2. It is a 2D array. Now we are converting it into, we are converting it into a 2D array. But it consists of 4 rows. And 2 columns. Now we want to reshape our array into 4 rows, and each row consists of 2 columns. So this is a given array. So here 1, 2, 3, 4, 4, 5, 6. This is our given array. It is also a 2D array. Next we are changing the shape of the array. Again we are changing it to 2D array, but the number of elements in each row and column will change. Okay, so here we are converting it into 4 rows with 2 columns. So this is 4 rows. Each row consists of 2 columns. Here the dimension is not changed. In the previous example, we have changed the dimension. 1D array is converted into a 2D array in this case. Okay, so here 1D array is converted into 2-dimensional array. By using reshape, we can convert 2D array to 2D, but having different number of rows and columns by changing the number of elements. So here this is also consists of 2 rows with 4 columns. Here we are converting it into 8 rows. Each row consists of only 1 columns. Okay. Again, the dimension of the array is same. So in both cases, the dimension is same. This is also 2D array. The resultant array is also a 2D array. So this is different variation. Here the dimension is not given. So reshape of 8, so in this previous case we have given reshape of 8, 1. So it will convert it into 8 rows, 1 columns. So here the column is not specified. So this will convert it into a 1-dimensional array. Now this 2D array is converted into a 1D array. So here we are giving only the number of elements. Here the number of elements is 8. So by using reshape, we can convert 1D array to 2D and vice versa. Another one is copy and view. As I already told, So copy will create a new array. View will share the same array. So in A12, we are having 1, 2, 3, 4, 8, 9. So X is a copy, Y is a view. After that, we are changing the content of A12. The first element of A12 is changed to 1000. Next, we are printing A12 X and Y. So A12, the updation will be there. So X is a copy. It will have a separate memory. So whatever the updation we have did in A12 will not be reflected in X. In view, that will be reflected. Then concatenation. So there is a function concatenate that is used to combine these two arrays. So here we are having 1, 2, 4, 5, 6, 5, 6, 7, 8, 9. So this will concatenate along column. So we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first concatenation along row. This is second concatenation. This is axis equal to 1. Okay, if it is axis equal to 1, this will do the concatenation along row. If axis equal to 0, by default is 0, it will do the concatenation along with the column. So we are using the same function. If axis equal to 0, it will do concatenation along the column. If it is 1, it will do concatenation along with row. So another one is split. NP dot, this is a given array consists of 12 elements. Then NP dot split of array comma 3. So it will divide the array into 3 sub-arrays and each array consists of 4 elements. Here totally 12 elements. So 4 divided by 3 is, 12 divided by 3 is 4. So each one consists of 4 elements. Another one is search. So if you want to search a particular element in the array, we can use the function var, np.var, then array name equal to 12. So here 12 is present in only one position in the corresponding index 10. So it will display 10. Suppose if you want to display, check 4, it will display. So 4 is exist in 2 places. So it will display the corresponding index of 4. If it is not, it will display null. Then next one is sort. This will sort in ascending order. Then this is sorting for 2D. What is for 2-dimensional? So here you see the first row consists of 3, 2, 1, 4. First row consists of 3, 2, 1, 4. This is the given array. -1, 6, 7, 8. Then we are np dot sort of A5 will do the sorting based on the row 1, 2, 3, 4. So first it will do sorting of this first row and it will do the sorting of the second row. Okay, so -8, -1, 6, 7. Okay. So this will do row wise sorting. If you give axis equal to 0, so here A5 comma 0, it will do the sorting in column wise. So this is so in this column, the -1 is lower, -1, 3, 2, 6, 1, 7, -4, 8. So it will do the sorting based on column. Okay. So by default, it is row. So another one is to generate the random numbers, random integer as well as floating point. Then if you want to generate only one random number, you can give random dot randint of 0, 10. So this will generate only one random number. So here the random number generator is 1. The second one is random, it will generate an integer random number of 3 numbers. Size equal to 3, it will generate a 3 random numbers. So it generated 0, 4, 9. The next one is random int between 0 to 10. Then we want to have a random number of 2 dimension, 3 rows, 4 columns. So this is a random number with 3 rows and 4 columns. The last one is it generates a floating point random number between always the floating point random number will generate between 0 to 1. Okay. So this will generate 2 numbers. If you give the argument, that will generate that number of random numbers. If the argument is optional, it will generate only one floating point random number in the range of 0 to 1. So this is how to generate the random numbers. Any doubt up to this? Any doubt in this up to this? Okay, now we will see this pandas, then we will see the hands-on in pandas. So already we have discussed about the NumPy. So in pandas, there are rich data structures and functions are available to work with the structured data in faster manner. That is the advantage of using pandas. This is built on top of NumPy with its high performance array computing features. So here it has flexible data manipulation capabilities. So we can read data from spreadsheet, or you can read data from the CSV file, or we can read the data from different relational databases. It has the sophisticated indexing functionalities, like by using colon operator, you can perform different operations like slice, dice, aggregation. We can select a part of the data. So suppose if you want to create a data set, so here it is called as data frame. Okay. Suppose if you want to work with pandas, first we have to import. So import, that is from pandas, import data frame, or you can give import data frame as df. You can use different notation at your convenience. So here I have used from pandas. Pandas is a package. From that I imported this data frame. So here car is a set, and as already told, anything within curly braces, it is called as set or dictionary. So here we are having a colon operator also. So inside this braces we are having a colon operator. So this is called as a dictionary. It's a brand. If the keyword is brand, if ID is brand, it has different values. Okay, it is like dictionary. So if for a single word you will have a multiple meaning, word and meaning. Similarly, here brand is keyword, and then the value for this brand is this Honda, Toyota, etc. Okay, then price is another keyword. Price is another key. So the price means it has different values. So this, okay, this is called as dictionary. Okay, so in this dictionary we are having two things, two keyword. One is brand, another one is price. Now we are converting this dictionary into a data frame. Okay. So how we are converting means this df is a variable name, df equal to data frame. Data frame is a keyword. So data frame, I want to convert my this data into a data frame. Then only I can do different types of operations using pandas. So data frame of car. So this is my variable car. So in this car, I want to have the column as brand and price. Okay. So inside the car, I am having two key values. One is brand, another one is price. I want to make this brand and price as column for my data frame. So what I am doing here is, I am creating a data frame. I am converting this dictionary into a data frame. That's all. Data frame of car, comma. So I want to have two columns. One is brand, another one is price. Next, I am printing the data frame. So this will print. So brand equal to, these are all the different brand. Honda, Toyota, Ford, Audi. Then a different price of each brand is this one. So this will convert this dictionary into a data frame. So this index is automatically appended by the data frame. This is the row index. So totally we are having 4 rows. Starting index is 0, ending index is 3. Okay. So here either, so in real time, we will not create a data frame like this. So usually we will have some data in different formats. Either you can have your data as Excel sheet, or you can have your data in CSV format, or in some other RDBMS format. So in that case, we can use this different options to read the data from our file. Okay. So either if the data is available in your hard disk, you can use this upload function to read the data. So you are working with Colaboratory. If the data is available in your hard disk, you can make use of this function, files.upload function, to read the data from your hard disk. So first I am doing import pandas as PD. So here it is not necessary to give only PD. So this is alias name. You can give anything. So if you give PD, it is a meaningful one. Okay. So one is you can upload the file from your hard disk. So if you want to upload your file from your hard disk, so you have to import this file from google.cola import files. You want to import files, then you have to make use of this function, upload function from the package file, files.upload. Then you will select a particular file. That particular file is moved into the variable uploaded. Then you can make use of that file for further processing. Or if your file is available in the drive itself, then you can use this pd.read function. If you are having the file in CSV format, you can use pd.read_CSV of. Then you have to give the entire path. Okay. So here I have given only the file name, but you have to give the entire path. Okay. So in your drive, the iris.csv will be available. You want to read that file means you can make use of this function pd.read_csv. That within parenthesis, within single quote or double quote, you have to give the entire path of your file. So I will explain how to get the path of the entire file. Okay. So you will see. Suppose if we want to access your data, if you want to access the data from your drive, first you have to mount your drive. So for that we are using drive.mount of this content/G drive. This is called as Google Drive. So I will explain during the hands-on session. Okay. So this read function. So in pandas there are different read functions are available. If the data is in CSV file, you can use this read_CSV. If it is in Excel file, you can use read_Excel, etc. So these are all different functions which is used to read the data from different data sources. So another one is this. So in data frame, suppose if you want to know in your data set, we are having different columns. If you want to know the information about that data set, you can make use of these functions. So data type will give you the list and type of the columns. If you give columns, it will list what are all the columns available in your data set. If you say axis, it will list the row index. Suppose if you are having some label for your label called rows, it will display the row index. So this already we have seen. This will display the number of dimensions. Size will give you the number of elements in your data set. Shape returns the number of rows and columns. So the dimension will give you whether it is 1D or 2D. The shape will give you the number of rows and columns in the given data set. Okay. So these values will give you the values of the corresponding data frame. So these are all different attributes in the data frame. Okay. So we are having thousands of records. So it is not possible to display all the thousands of records. Suppose if you want to display only sample records, we can make use of this head and tail function. So the head function will display the first 5 records. Head of, if you give open and close, it will display the first 5 records. If you give the n, head of 10 means it will display the 10 records. So it will display first and last n rows. So the describe will give you the statistical information for numerical attributes. The describe function gives some statistical information like what is the mean of the corresponding column, what is the median of the corresponding column, minimum, maximum. So it will give you the statistical information about the numeric columns. So the minimum and maximum function returns the minimum and maximum value of the numeric columns. Similarly, mean, median, standard. If you want to find mean, median, standard deviation for each and every column, you can make use of this function. So the sample, you are having a large number of records. If you want to display a sample reports, you can use this sample of n. Okay. Sometimes the records will have some in real-time data will not be a complete one, so it will have some missing values. So if the record is having missing value, will not be useful for your machine learning purpose. So in that case, if you want to remove that records which is having the null value, this drop NA function is used. So this NA means it's a null value. So this drop method is used to delete the records which is having a missing value. Okay. So this is some examples we will see with this hands-on session. So these are all the different functions used to check whether our data is having a null value. So the first one is null and not null is used to check whether our data set is having a null value. If it has a null value, it will return a true value. If it is not having a null value, it will return a false value. So this is used to check whether our data set is having a null value. Drop is used to remove the rows which is having a null value. This fill NA, replace and interpolate. These methods are used to fill the missing value with different values. Suppose we are having only 200 records. So out of 200 records, 10 records are having a missing value. So you don't want to remove that record. Instead of that, you want to fill missing value with some other mean value or standard deviation value. Means you can make use of these three functions: fill, NA, replace, and interpolate. So these three functions are used to replace a missing value with some other values. Okay, this is how to handle the missing value in the data set. Okay. So this is different functions. Drop NA, drop the missing observations. Drop NA how equal to all means if a row consists, if all the columns of the row is not a value, means the corresponding row will be removed. Okay. So here we will see all the things in the hands-on session. Drop NA axis equal to 1, how equal to all. So this will do drop the column. If you want to drop a particular column which is having all, that is all the element, all the values are not missing value, means you can drop that particular column. So in that case, you have to say axis equal to 1. So if axis equal to optional means it will drop the rows. So here drop NA means it will drop only the row. Okay. Suppose if you want to drop a column, you have to explicitly give axis equal to 1. Then only it will drop the column from the data frame. Drop NA crush equal to 5. So here, if a row contains at least non-missing value, then it will, if a row doesn't have at least 5 non-missing value, then the corresponding row will be dropped. Okay. So fill NA with 0. Wherever the data frame is having a missing value, that is replaced with 0. This is null returns true if it is having a null value. Okay. So if there is no null value, this not null will return. Okay. Next, suppose if you want to visualize our data set, we can use this data visualization. So for that, we are using this matplotlib and cbonds. Okay, we will see in hands-on all these things. Are you able to see this data frame window?
Yes, ma'am.
Yes, thank you. The first one is, if we want to use a data frame, the first one is import pandas as PD. Import pandas as PD. Then here I created one data frame, one dictionary, data equal to. So here I am having the name and age. Okay. So this is a key value pair, name. Another one is age. It is also a key value pair. This is a dictionary. Then I am converting this dictionary into a data frame. Okay. If our data set is very small, we can easily understand the functionality of all the functions. So data frame equal to pandas.pd.data frame of data. I am converting this dictionary into data frame. So I am printing the data frame. So print df. So this will print all the 5 records with the appropriate column name. So by default, it will take column as name, first column as name, second column as age. Okay. So if you want to explicitly give, you can do that also. Okay. So first I have created one dictionary with 2 records. So one is considered as, name is considered as one column, age is considered as another column. So this was called as data frame. Now I want to print the, sorry. So if you give df.columns, it will print the name of all the columns. So in my data set, I am having only 2 columns, name and age. So this will print the column name as well as data type of that object. Okay. Suppose if I want to display a particular column, I can use this print df of, it is a 2D array. So it is a 2D frame, it is a 2-dimensional. So here I am giving df of 2 square bracket 10. So here I am using the column name to access the element. So it will display all the name. So in my data frame, I am having 5 records. So all the 5 records name will be displayed. So either I can use, if I know the column name, I can use the column name. Sometimes it is very difficult to remember the column name. So in that case, we can make use of this ILOC function. This is index location. Okay. So if we are having this is a large data frame, it is very difficult to remember the name of all the columns. So in that case, we can make use of this ILOC. So this ILOC means index location. So this will display all the rows. The first one is colon, refers, the first index is colon, it means all the rows. It will display the first column. So the first column is age, 0th column is name, first column is age. So it will display all the rows and age. The second print will display, the first print will display the name of all the records. The second df.iloc will print the second column, that is second, that is one means here it is a second column. Second column is, it is an age. So this will print the age of all the 5 records. To access a particular column or to access the content of the data frame, either we can use the name of the column or we can use the integer index. So ILOC stands for integer location. So here I want to display all, that is starting from 1 to 5. Starting from 1 to 5, I want to display all the columns, name, comma, age. This is row index. So in row index, I am giving start delimiter and end delimiter. Df dot LOC of, so this is called as ILOC. If you are using ILOC, you can use only the integer index. Okay. I4, it is an integer location. So see this, in this, here it is not ILOC, it is an LOC, df dot LOC. We can use LOC function also to retrieve the content of the data frame. So it takes two arguments, one is row, in the second one column. So here we can use integer index as well as new column name. Okay. So to define the row, I am using the integer index. To define the column, I am using the column name. Okay. So this will print the row index from 1 to 5. So in my data frame, I am having only 5 records with starting index 0 to 4. So this will print only 1, 2, 3, 4. Okay. So LOC is, in this LOC, you can have either integer index or you can have a column name as the index, or you can have combination of both the things. In ILOC, you can use only the integer index. Here, if you give ILOC of, if you give colon, comma, if you give name, it will say an error. So here you can give only the integer index. So ILOC and LOC is used to retrieve the content from your data frame. So this is a different way of using this ILOC. So this is our actual data frame. So in actual data frame, there are 5 records. It will print the actual data frame. Then df dot ILOC of, this will define the first row. First row, then all columns. So in first row, all columns, this will display Tanu and 23. Okay, here it will display name is Tanu and age is 23. Okay, here the second one is df dot ILOC of I colon comma from first row to all the rows. The meaning is here only one comma colon. Here you see the difference. 1 colon comma means the starting index is from 1, ending index is not given. So ending index is not given means from 1 to all the records. So here it is from 1 to all the records. Then here in the second one, all columns. So here 1 to all the records, it will print all the columns. So 0th record is not printed here. All record from second. This is all record from second. So all record in from second, 0th record is not printed. So here df dot ILOC of 1, 2, 3. So that will print the second and third record. So this will print second and third record. Okay. So by using this ILOC and with colon operator, you can extract different portions of the data frame as your wish. Okay. So another one is, so if we want to work with machine learning, we want to know the insights of the data set. So here I am using from Google Colab import drive.mount. Here I am going to take my data from my drive. Okay, I am having the data in my drive. So if I want to get the data from my drive, so you have to use drive.mount of content/drive. So once if you give, so I will execute this in some other slide. So already my drive is mounted with this notebook. I am executing this line in some other so here I am going to use data from my drive. So if I need to take the data from my drive, I have to execute this one. So I want to import drive. Okay. So when you give this command, some authorization code will be given here. You click this link. If you click this link, it will ask for a Gmail account. So by using which Gmail account you are working with this Google Colab. So here I am using with this account shanti.s.mca. So I have selected that account. So you have to give allow. So when you give allow, it will give a code. So you have to copy this code and you have to paste this code here. Okay. So once if you paste this code here, now your drive is mounted with this notebook. Okay. So once if you give the authorization code, your drive will be mounted here. Is it clear? Suppose if you want to take a data from your drive, first you have to mount your drive with this notebook. Okay. So for mounting this, you have to use from google.colab import drive, then drive.mount. Once if you execute this code, it will ask for some permissions, authorization code. So you have to paste that authorization code to further processing. So here already this is mounted with this drive, so there is no problem. Next, I am importing pandas. Now I want to read my data from my drive. Okay. So how to get my data? So this is my drive. So there is a folder Colaboratory. So it is automatically created. That is Colab notebook. So in this Colab notebook, I am having a data iris. So I am going to use this iris missing data, not a number 1.csv. So here you go and copy path. Okay. So if you can copy path. Suppose you are taking the data from this file. So you have to get the path of that file. So copy path. So here you can paste. So I am going to read the data from my drive. Okay. So df equal to pd.read_csv. This is the function which is used to read the data from the CSV file. So pd.read_csv. Then you have to give the path of your file. Okay. So just I am printing the df. So this will print. So in this, this is an iris data set. This is a well-known data set used in machine learning algorithm. It consists of 5 columns. That is sepal length, sepal width, petal length, petal width, and class. So these are all the 5 columns in the data set. So print of df will print the content of this data set. Now I want to know the data type of each attribute. So df.data types. This will display the data type of all the attributes. Now I want to know what is the number of rows and columns in the data set. So df.shape will return the number of rows and columns. Dimension will give you the dimension. Shape will return the number of rows and columns in the data set. So here there are totally 135 rows and 5 columns. So here, as already told, describe is a function which will give you some statistical information about the numeric data set. So in our data set, we are having 5 attributes: sepal length, width, petal length, and width, along with the class. Here class is a nominal attribute. So this describe will give you the statistical information only for this numerical attributes. Okay, what is the total number of records, mean value, standard deviation? That is the mean value for 25, 75, 50%, 75%, etc. Okay. So here the information give you the information about all the attributes. What is the total number of records, whether that column having a null value, what is the data type. So this is column. So totally we are having 5 columns. Then we are having 190 not null value. So this will give you the number of columns having the not null value. What is the data type of each column? Okay. So here there is some missing value in this. So totally 135 records. So here we are not having the count as 135. We are having 119 not null, 124 not null. In class, we are having 133 not null object. Okay. So that will give you some information about the data frame. Then head will display the head of 10 means it will display the first 10 records from index 0 to 9. So this will display the first 10 records. Now this you see another one. It also display the first 10 records, but we want to display the first 10 records which is having a null value. So here df dot is null. So this is null function is used to check whether the data frame is having a null value. Okay. So here axis equal to 1, it will check along x-axis, along row. Okay. So if data frame is having any null value, you display that only. So this will display the first 10 records which is having a null value. You see, 0th record having index with 0 having a null value, 1, 2, 3 having 4, up to 4 is having null value, then 5 to 7 record doesn't have null value, so it is not displayed. You see here, 5th record, this is the 5th record, this is head of 10. So in head of 10, 5, 6, 7 is not having any null value. So here this 5, 6, 7 is not displayed. So this function will display only the record which is having the null value. So df dot is null, it will check the record is having a null value. If it is null value, it will display it. It will display the first 10. So if it is tail means it will print the last 5 records. Here argument is not given. If argument is not given, it will display only the last 5 records. So totally we are having 135 records from index 0 to 134. So it will display last 5 records. So here this function will display the last 10 records which is having a null value. Last 10 records with null value. So from 127, 126, etc. Okay. So this is to display the null value. If you want to know the minimum and maximum, you can give the df dot minimum of and df dot maximum. This will calculate the minimum and maximum for numerical attributes. Okay. So here the numerical attribute is SL, SW, PL and PW. So it will display minimum, maximum. If you want to calculate mean, median, you can do all the things. Okay. Next, I want to, in my data frame, the last column is class label. So in this, there are 3 classes, Iris versicolor, Virginica and Iris setosa. Now I want to know what is the total number of records under each category. So for that I can use this count function, df.iloc all rows. This column refers all rows. This -1 refers last column. So last column is the class label. So I want to count values. Value underscore count means it will count the occurrence of each category. So in class label there are 3 class labels. So in each category, the first 2 category, 45 records are there. In Iris setosa, 43 is there. Then remaining 2 is, it is a not null. So remaining 2 classes are having a NA value. You see here in class value there is a NA. So totally 135 records. So totally 135 records. So 135 here, it is 2 is missing value. So it is not comes under this Iris setosa. This value count is used to count the occurrence of a particular value. Okay. So this is also used to count the numerical value. So in the first column is sepal length. So if it is 3, with value 3, there are 23 records. Value 2.8, 7 records. 3.2, 11 records, etc. Okay. So this is just to know the information about the data set. Next, how to handle the missing value. So here this will print number of missing value in each column. Okay. So in sepal length, there are 16 number of missing value. In sepal width, 11. Petal length, 21. 11. In classes, there is 2. So here df dot is na dot sum function. So this will give you the count the number of missing value in each column. So in this data frame, there are totally 5 columns. This isNA.sum will count the, find the number of missing value in each column. Or you can use another function df.isNull of sum. Okay, here this missing value, that is n, either you can use NA or isNull, both are same. So this is used to count the number of missing value in each column. Okay, so this function is used to count the number of missing value in each row. Okay, so in first row there are 2 missing values, second row 1 missing value, fourth row 1 missing value, like that. So that will count the number of missing value in each row. Okay. If you see this one, number of missing value in first row is 2, second row is 1, third row is 2, etc. Suppose if you want to know the number of missing value in each row, you can give this axis equal to 1. Axis equal to 1, it will find the number of missing value along the x-axis. So this function is df.isNull of sum of axis will display the rows which is having the null value. So here it will display all the rows. This will give you the number of rows having the null value. So totally 53 rows are having the null value. So this function will give you the total number of missing entries in the data frame. Okay. Suppose if it is in a single row, if it is 2 null value means it is treated as 2. So this will give you the total number of null value in the given data frame. IsNull dot values of RA val. So you want to find the sum of all the values. Okay, this is to count the total number of null values in the data frame. Then this will print the shape, number of rows and columns. And then I am removing the rows which is having the null value. So df dot drop NA. So drop NA will remove the rows which is having the null value. Okay. So totally the number of records in the actual data is 135. So df dot shape will print the 135 comma 5 columns. Then we are dropping the rows which is having a null value. After removing the samples, we are having 82. Okay. So after removing the rows which is having null value, we are having the only 82 rows. So this is to remove the null values. Okay. So this is used to remove the null value. That is, the rows is, at least the rows should have 4 not null value. You see this one. This is before removing. So before removing, you see this first row. In the first row, we are having only 3 not null values. 3 not null value. But what we have given us, it should have at least 4 not null value. So here after removing, the row 0 is removed, because in row 0, we are having only 3 not null values. Row 0 is removed. In row 1 also, we are having only 3 not null value. In row 2, we are having 4 not null. So row 2 is retained. That is, with index 2 is retained. This is retained after removing. Okay. So this is based on some constraints. We can drop the missing values. Okay. Suppose if a row is having all the null value, we can drop it. So here we are not having a scenario like that. Df dot drop NA of how equal to all. So if a row is having all the element as null value, it is replaced. Then how to replace a missing value with some other value? So df dot fill NA with 0. Here all the missing value will be replaced with 0. Here the first row we are having not a null. Here that is replaced with 0. Okay. So here fill NA with 0. All the missing value will be replaced with 0. Then if you want to replace by a specific constant, you can do like this. Fill not null. I want to replace SL with 0, SW with 1000, PL with 10, PW with -200, and classes I want to define with non-defined. So you see here, before missing value, here we are having NaN. So in this class NaN. So after replacing, SL is replaced with 00, SL is replaced with 00, PW is replaced with minus 200, and class is defined with not defined. Okay. So if you want to replace the missing value with a special constant, you can do it. Or you want to replace the missing value by using some mean value and median value, you can make use of this aggregate function. Suppose if you want to replace with mean value, we can use this df dot mean. Or you want to replace with the median value, we can make use of this df dot median. Okay. So this was used to find the sum, mean, median, minimum of all the things. So here we are replacing with, you see this code, fill not a number with, so this portion is to find the mean of this first column. Okay. First you are finding the mean for this SL column, and we are assigning that mean to this missing value. Similarly, we are finding the mean for second column. That mean will be assigned to the missing column of SW. Okay. So for this column class, I am using only the constant. So this is assigning, handling the missing value with mean. So all the missing value will be replaced with mean. Okay. So here see this NaN, it is replaced with mean value of SL column. So here PW is replaced with mean value of PW column. Okay, it will calculate the mean of the corresponding column, and that is replaced with that missing value. This is replaced with some aggregate functions. Okay, any doubt up to this? Okay. Suppose you want to work with the machine learning algorithm, first the pre-processing is one of the important tasks. So if your data is having some missing value, either you have to remove that samples, or it should be cleaned with some methods. Okay. So these are all some basics. Any doubt up to this? Okay, the next portion is visualization of the data. So before applying the machine learning algorithm, first we should know the distribution of our data set. Okay. So by using that numerical data, or by using the data in the Excel sheet, it is very difficult to know the distribution of the data set. So in that case, we can go with this visualization. So here we can use matplotlib, or we can use Seaborn to visualize our data. Okay. So here I used both the things, Matplotlib as well as Seaborn, to display the graphical representation of the data. Okay. So in this case, I am taking the same data set. Here in this data set, there is no missing value. Everything is a perfect data. So here we are having 150 rows and 5 columns. Okay. So now I want to know the frequency of petal length. So what is that? So the this is the x-axis defines the minimum and maximum, that is data range of this PL. Data range of PL is 1 to 7. Then this y-axis defines the frequency, that is number of occurrence of H value, that is a histogram. Okay. So if you want to display your data in a histogram form, you can use this one. So this plot is the alias name. Import matplotlib.pyplot as plot. Okay. Suppose if you are not using alias name, you have to use everything matplotlib, pyplot, dot, then you have to use. Then Seaborn as SNS, pandas as PD. Then plot, this is matplotlib, plot. I want to display the histogram of my data frame. My data frame is DF. So in that I want to display only the petal length. So this is the column name. Okay. So PL is column name. If you don't know the column name, you can use this ILOC. DF dot ILOC of, then double square bracket, you can use the index. If index is 0, you can use df dot ILOC of 0. Okay. So here, if you know the name, you can make use of the column name. So next plot dot GCA dot set. I want to say the title frequency histogram. I want to set my X label is PL and Y label is frequency. You can give. Okay. So this will display the frequency histogram of this PL. Okay. So this is frequency histogram of SL by using the same matplotlib. So here by seeing this histogram, you can know the distribution of the data set. So whether it is normal distribution or it is skewed distribution like that. Okay. So here it is in all range we are having a equal number of records. Okay. This is a normal distribution. Then based on the class label, I have displayed the histogram. So what is the total number of records in this iris setosa? What is the total number of records in second class and third class? Okay. So here this is used to know whether your data set is balanced or unbalanced data set. So this example is it's a balanced data set because in each class we are having a equal number of records. Okay. So in each class we are having a 50 records. So this is a balanced data set. So why I am displayed this histogram for this class label is to know whether the data set is balanced or unbalanced. Then this is to display only the same thing. That is to count. Then another one is this is to display the pie chart. So here what is that the same thing. So instead of this histogram, the same thing will be displayed in the pie chart. So depending upon your requirement, you can go with different types of chart. So here the data is available in TT. So I assign my data in TT. So here I am using plot.py. This is your data set. TT is our data set. Then labels equal to, so I am having three labels: iris setosa, iris versicolor, and iris virginica. So in this DT, I am having only these things. Okay, this is available in this DT: iris versicolor 50, iris setosa 50, iris virginia 50. This is the content of DT. So by using that data, I am displaying this pie chart. Okay. So plot.show will display the chart. So this is using some additional attributes. So here used explode. So suppose if you want to show some portion of the some portion explicitly, in that case you can use explode. So here I am having totally three attributes. That is three attributes. So I want to explode the second one, that is iris versicolor. So here I have given 0.1. So this is exploded 0.1 from this actual pie chart. Then suppose if you want to display the percentage here, so here you have to have this attribute auto percentage. Then shadow, if you give shadow equal to true, this will give you in 3 dimensions. This is very simple. Here there is no attribute is used in the pie, only this labels and data alone given. So TT is having the data and this is the labels for this pie chart. This is the label. It will display the label. If you want to have a rich chart, you can make use of the different attributes. So another one is for the same data, for same sepal length, I have displayed the histogram. So here I am using the Seaborns. Seaborn is much richer than the matplotlib. So this will display the plot. This is also histogram. This will also display the density of the data. Okay, so by seeing this density, we can assume this is a normal distribution. This is with respect to sepal length. This data is distributed normally. Okay, so this is SNS. This is Seaborns display plot. I am using the function display plot. Then this is your data. This is our data. So data df is a data frame I am taking only the column SL. There are 5 columns. I am considering only the column SL. Then histogram equal to true. Then what is the bin? So what is the, this is called as bin. So here I assume 180 divided by 5. Then color for this plot. Then width of this line is 4. Okay. So this will display the density plot and histogram. So the same thing is for next attribute. The same thing for next attribute. Okay. So here I have not used this line width and all. So here I have given line width is 4 and dark blue. So we are getting this line dark blue with bold. So here I have not used any attributes. So this will display the histogram as well as density plot of this SW data set. So it is distribution. Okay. So here this is also it is a normal distribution, normal distributed. Okay, this is with respect to PL. Okay. This is not normal distribution. Normal distribution with 2 different segments. Okay, this is with respect to petal width. The same plot with respect to different attributes. Okay. Another one is scatter plot. Scatter plot. The scatter plot is displayed by created by using the matplotlib. From matplotlib, import pyplot as plot scatter plot. So I am using df dot all rows. The first one is with respect to class label, and the first column. So this is with respect to class label and the first column is SL. Okay. So it will display the scatter plot. This scatter plot is drawn by using the matplotlib. Okay. So this is iris versicolor. If sepal length is between this 4.5 to 6, this data set belongs to iris setosa. Okay. So by seeing this, we can identify the distribution of that attributes. Then this is scatter plot by using Seaborns. SNS dot scatter plot. Then I am using 2 attributes, sepal length and sepal width, against this hue equality class, against my class attribute, against my target class. My target class is iris setosa and iris versicolor and iris virginica. Okay. I am displaying the data set against this class. Okay. So X attribute is sepal length, Y attribute is sepal width. So this will display the scatter plot. Okay. So by seeing this histogram, what you can infer is by using a straight line method, it is easy to differentiate iris setosa from other 2 classes. Okay. So you can have a straight line, but to differentiate this iris versicolor and iris virginica, straight line method is not possible. So we have to use a non-linear method. Okay. So by seeing this distribution of data set, you have to identify what type of method you have to use for learning. Okay. So this is scatter plot with respect to SL, SW against your target class. This is with respect to PL, PW against the target class. So here also this iris setosa is easily classifiable by using this PW and P length. Okay. So here by seeing this graph, what you infer is this PL and PW will be enough to classify this data set. Okay. So by using some non-linear method, we can easily classify our data set by using the attribute PL and PW. So another one is join plot. So here this join plot is used to combine the properties of 2 graphs. So this is scatter plot with respect to PL and sepal length against the class, and also it will display the distribution. Okay, you see the distribution of this attribute. This is distribution of PL with respect to each class. Distribution of PL with respect to each class. This is distribution of SL with respect to each class. Okay. So this will combine the properties of two graph. Join plot. My data is in DF. X-axis is petal length, Y-axis S length. So here this is target class. Q is one of the attribute in this join plot. So here you have to give the target class. Okay. So this is used to give a rich graphical representation. Join plot. Another one is pair plot. So here this join plot is here at any time you can make use of any two attributes. In x-axis one attribute, y-axis another attribute. It will display the scattering of the data set against the target class. So here this pair plot is for your entire data frame. So data equal to df, data equal to df, q equal to class. Okay. So for entire data set, it will display the scatter plot by combining two attributes at a time. So first it will combine SL and PW. It will display the scatter plot of this SL and PW with respect to this target class, and also it will display the distribution of the data set with respect to all the three classes. Okay. So this is SW, PW. This graph is with respect to SW and PW. Here the corresponding distribution also will be displayed. Okay. This will display the scatter plot along with the distribution graph for the entire data set. Okay. Seaborns dot pair plot of your entire data frame, then against your target class. Okay. So this is to know the some insights about the data set before going to the machine learning algorithm. Okay. So here we are having data. You can do this type of displaying the graphical information. Suppose if you are having a continuous data, we can make use of different types of chart. So here I am using another type of data. It consists of some continuous data. This is information about a superstore sales data. So there we are having so daily different products will be purchased. So there you will have these are all the different attributes in that superstore. Order ID, order date, then what are all the items ordered, what is the quantity, what is the cost, and what is the mode of payment, what is the mode of shipment, everything. Order ID, order date, shipment mode, customer name, segment, state, country, market, region. There are so many attributes are there. These are all the different columns. So here the total number of records is 51,290 records. Okay. So from that, suppose if you want to infer something, we can make use of this visualization techniques. So first it will print the its execution time is depends on the speed of our internet work. So it will print the shape, it will print the head, and then here we are checking whether it is having a null value. So here there is no null value. All the columns are having some entry. So here the sum of null value is 0. So here what we have displayed is based on the category. So there are different categories. There are 3 categories: office supplier, technology, and furniture. So under the column category, there are 3 different values. So based on that value, you want to display here data frame of category dot value underscore count. So in each category, you want to count what is the occurrence of each category and plot kind equal to bar. So you want to display the bar chart. So it will display the, so here you see shipment mode. There is a category. So in category, so in this category, there are different values. So based on this category, first it will find the total of each category and it is displayed. Okay. So df of category dot value count of plot of kind equal to bar chart. So this will display the bar chart. Okay. So the same thing is displayed by using a line chart, the same content, the category value count, but it is not good. Okay. So depending upon the situation, you have to choose the appropriate chart. So this is good for showing this information, but if you go with line chart, it is not suitable for this scenario. Next one is, so in this data set, so here now I want to show the sales, month by sales. I want to show the month by sales. So here in this data set, I am having date by sales. Okay, order date is date wise 1111. So first I want to count what is the total sales in month 1, month 2, etc. First I am counting this one. I am converting my day month year format to year month. I am converting my day month year format to year come, and I am based on this order date, I am converting it into month year format. Okay. Then based on that month year, I am finding what is the sales in each month. Okay. So this is sales in each month. First, you have to do some manipulations to get the monthly sales. Okay. So in my data set, the data is in the format of day, month, year. So for a single month, we will have n number of transactions. That is, all things will be collected. And here we have calculated the monthly wise sales. Now I want to display this in a graphical manner. Okay, so I am using plot dot figure of using. Then here in trend, I am having my data is in the data frame df underscore trend. Okay, so now I want to display the month value and sales value. X-axis is month, x-axis is month, and y-axis is what is the sales. Okay, so in my data set, I am having the data for day-wise sales. Okay, first you have to find the sum of month-wise sales. After finding the sum of month-wise sales, we are drawing the graph. Okay, so month-wise sales is available in the DF trend. Okay, so here we are using plot dot plt dot plot of, this is our data. So data is available in df underscore trend of month comma df underscore trend of sales. So this will display. So here why we are using this plot dot x ticks of rotation equal to vertical. So this is x label. Okay, I want to display this x label in vertical direction. So plot dot x ticks of rotation equal to vertical. So size equal to 10. So if it is displayed in horizontal, it will be very congested. So here I used plot dot x ticks of rotation equal to vertical. So this is to display the month-wise sales. So if you use this bar chart, it is not good for this scenario. So here this line chart is used. Okay. Suppose I want to know the top 10 products. You can make use of this one. Group by product name dot sum of sales. So this will display the top 10 sales. So first it will find the sum of all the things. Then from that I am taking the top 10. Sort values in place equal to true, ascending equal to false. So I want to sort it in descending order. So highest value should be first. So this will be in the descending order of sales. So this is the highest sales, product name with sales rate. So now I want to know what is the preferred ship mode. There is a column ship mode. There is 4 different values. I want to know which one is the preferred ship mode. So here I am using SNS dot count plot of, I am counting the ship mode. Okay. In ship mode, there are 4 different values. This will count. Based on that count value, it will display the path chart. So here it is, graph is not used. So this is just to know which are the most profitable category and subcategory. So there are categories there. Under the category, there are subcategories there. So this will display the profit of each subcategory under each category. So here, first we are grouping it by using category and subcategory, and then we are finding the sum of profit. Any doubt up to this? If you have any doubt, you can ask me. Otherwise, we will close this today's session.
Hope participants not having any doubt, ma'am.
Okay, we will close this session.
Yes, ma'am. Thank you so much for your informative session. You have demonstrated the Python code in Code Laboratory platform in detail. Hope all the participants will get the depth knowledge in this topic and also enjoy the session. And also, I would like to thank all the participants for their support and cooperation. The feedback link is posted in the chat window. All are requested to fill the feedback form. So tomorrow's session starts at 10 a.m. in the topic of linear algebra and calculus to start the deep learning. Thank you all.
Thank you, Dr. N. Paimudi.